Hey guys, today we're going to be talking about polygons. We're going to classify and find the angle measures of polygons, the interior and the exterior. So the formal definition of a polygon, a closed figure formed by three or more segments called sides. Each side intersects exactly two other sides, but only at their endpoints. So you can draw any figure. I could just do this, straight line. They have to be straight segments. And see, this is open, so it has to be closed. So to close it, that's one example. Just any figure, a square, a rectangle, anything that you've learned already from middle school. A triangle is a polygon. That's the smallest polygon is a triangle. Okay, so any figure with straight sides, right, that's closed, that's a polygon. Okay, so non-examples, so this is not a polygon. See this right here? This one is not a polygon because it intersects, see right here? This side and this side intersect this side and this side. So they cannot crisscross like this. And they can also not be open like this. See this one? This is not, because it's open. It has to be closed. And it also cannot be a circle, cannot be anything, circle or anything with a curve. This cannot be one because it has to have sides, straight segments. Segments are straight lines, so they're, see this like this, no curves allowed. Okay, go ahead and write your own definition here, like in your own words. You can just write whatever will help you remember what a polygon is. So it's just any figure, three or more sides that are straight lines, no curves, have to be closed, cannot be opened, right? And can't crisscross. So octagon, decagon, all those that you've learned, those are all polygons. Triangle, square, rectangle. Okay, let's go on to the next part. There's two categories of polygons, convex or concave. So the easiest way to remember is, see the word here, concave? So that means with cave. So that would be any polygon, so any figure with straight sides, right? No curves. And they have to close, so they have to all meet, but it has an indentation. See that? Like a little cave. It has a little cave. So really what it means, so if you draw lines in here, extend the lines and it goes inside, see this, inside the figure, then it's concave. But you can just remember it by if it has a cave in it. So any indentions, I could draw another one. So let's say I'm drawing a rectangle, right? I'm trying to draw a rectangle, but I want to draw a concave figure. I cannot draw a rectangle because it has to have a cave in it. So this would be a concave polygon, okay? So a rectangle is not concave because a rectangle cannot have a dent in it. So any shape with a dent is concave. Convex is any shape without a dent. So it could be any shape at all. You can make a triangle, just anything. Oh, it needs to be a closed figure. I didn't close it. So there it goes. Okay, it can be anything as long as they don't go in. See that? Here we go. Okay, so go ahead and draw some examples on your own, on your paper. Okay, one more time because this is important. Concave is any figure with a cave in it. So it can have one cave or multiple caves. It doesn't matter as long as it has one or more cave. There we go. That's another concave figure. Draw two more on your page. This will be on your test, so make sure you know the difference between concave, and see it has the word cave. So on your notes, highlight cave. Okay, so with a cave. Okay, then we have an equilateral. See, equilateral polygon, all the sides are equal. A polygon with all sides congruent. So all sides congruent. See, the sides are marked congruent. An equal angular polygon, see the word angular? So a polygon with all interior angles congruent. So you see how all the angles are congruent? They're marked congruent, but the sides, this side is longer. So this is equal angular, and this one up here is equilateral. And if they're both equal angular and equilateral, then it is called a regular polygon. This is an important word. So if you see something called a regular polygon, then all the sides and all of the angles are going to be congruent. So this is, see, the interior angles are all the same, and the sides are all the same size. So they're congruent. That's called a regular polygon. Make sure you write that down, underline regular polygon. Regular means all of them. All the sides and all the angles are congruent. Okay, so now we're going to talk about the interior angles of a polygon. So notice these are the interior angles of a polygon. This is an interior angle. This is an interior angle. But I don't know what their measures are. This is an interior angle. I'm going to put a dash so they're not congruent because I don't know that. This is an interior angle. This is an interior angle. So I need to find out what is the measure of these angles, or what is the measure of the total of all these 1, 2, 3, 4, 5 angles. So the way you do that is you pick one vertice. So I'm going to pick this one here. But you could pick any one, but I marked it red, so we're all going to pick the same one. And I'm going to connect it to all the other vertices. So this one's already connected, so I'm going to do this one here. So that's 1. So notice I made one triangle. Do you see that? And here's another one. And then that's it. I can't make any more. So I made 1, 2, 3 triangles. So I have 3 triangles, and each triangle is 180 degrees, right? All 3 angles would be 180 degrees. So this is 180, this is 180, 180, 180. So there's 3 triangles, and each triangle is 180 degrees. So 5 sides, I have 5 sides, 1, 2, 3, 4, 5, and I made 3 triangles. Okay, so what's 3 times 180? Okay, good. 3 times 180 is 540. So the sum of the interior angles in the pentagon, so a 5-sided figure, is 540 degrees. So let's see what we did. Okay, so to find the interior angles, the sum of the interior angles, all I do was pick one vertex and then draw lines connecting to the other vertices, and then count how many triangles I have. I have 1, 2, 3. Each triangle is 180 degrees. We learned that a couple of months ago, right? 180. So I have 180, 180, 180 degrees. So that's 540. So total is 540. So if I add up all these angles right here, they would equal 540 degrees. Let's try this next one. So go ahead on this red dot, connect all the make your diagonals to connect the other vertices. So I'm going to connect mine. So there's 1 triangle, then I'm connected to this one. There's 2 triangles. There's 3 triangles. And I can't really do this because it's already done, but I'll show you. So even if I do the other vertices here, they don't make any other triangles. That's it. So I only have 1, 2, 3, 4 triangles. So I made 4 triangles. So 6 sides makes 4 triangles. Oh, so this should be a 4. So 4, not 3, 4. Can you guys fix that real quick? 4 times 180 is, go ahead and type that into your calculator and see. 4 triangles, each one is 180, so 4 times 180. And I always like to put a little triangle, I like to make a triangle right here, like this, so you know that each triangle is 180. So 4 times 180 is, good, it's 720 degrees. So do you notice a pattern here? 5 sides makes 3 triangles, 6 sides makes 4 triangles. It's just the number of sides minus 2. That's the rule, number of sides minus 2. So count these. There's 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. So this is 8 sides. So 8 minus 2 will be what? 8 minus 2 is 6. So there are 6 triangles in this figure. Let's check just to make sure. And I know for sure it does because I know that rule, which I'm teaching you. Just count the number of sides and subtract 2. And let's just prove it right here. So you don't want to do this all the time to every figure, especially if you have ones with larger sides. So there we go. So I connected every side, every vertice with the diagonal. So I have 1, 2, 3, 4, 5, 6 triangles. Yeah, we got it. 6 triangles. And each triangle is 180 degrees. So I'm going to do 6 times 180. So I'm going to put a triangle, put 180 triangles. So there's 180, 180 in each triangle. So 180 plus 180 plus 180 plus 180 plus 180 plus 180 to find out the total of all of these angles right here. So each angle, you add them all up. I don't know what each angle is exactly, but they're going to add up to be whatever 6 times 180 is. Go ahead and figure that out. What is 6 times 180 degrees? Good, it's 1080 degrees. So any octagon, no matter how large or how small, all the interior angles will add up to 1080 degrees. So an 8-sided figure has 6 triangles, and each triangle is 180 degrees. So you multiply 6 times 180, and that would give me 1080. So over here where it says, what do you notice? The number of sides will always equal the number of triangles. Oh, the number of sides minus 2. So right here, put the number 2. The number of sides minus 2 will always equal the number of triangles. So that's n minus 2 is the way we write it, n minus 2. So all you do is write n minus 2. That gives you the number of triangles, and you multiply that by 180 degrees. And that will give you the total. So count the number of sides of a polygon, then subtract 2, then multiply that number by 180 degrees to find the sum of the interior angles of the figure. Show all your work. We're going to practice that. So look at this one. Let's count the number of sides. So 1, I would mark them, 2, 3, 4, 5, 6. So there's 6 sides. So 6 minus 2, yep, is 4. And there's 4 triangles. So 4 times 180. So 4 times 180 is what? Go ahead and figure that out. What's 4 times 180? Okay, good. 4 times 180 is 720. So the sum of the interior angles equals 720. Okay, so they equal 720. All of them together add up to 720. So I have 105, I have 142, 88, 136, and 136 plus what gives me 720. So go ahead and add all of these up. Add 105, 142, 88, 136, and 136. So this all should have given you 607. So 607 plus what, right? Plus what gives me 720, and you just solve it. So I need to solve for x, so I'm going to subtract, right? Subtract 607 from both sides. So what is 720 minus 607? Go ahead and figure that out. Good, you should have gotten 113. So this measure of angle A is 113 degrees. Good, try this next one here. This one has a little bit more algebra. But just, I would add up, first count all the sides. So there's 1, 2, 3, 4, 5, 6 sides. So there's 6 sides. So 6 minus, what's that magic number? Good, 6 minus 2. So 6 minus 2 is 4. So there are 4 triangles. So 4 times each triangle is 180 degrees. So 4 times 180, go ahead and figure that out. Okay, it's 720. So that means that every angle, so this angle, 100, 130, this one, this one, this one, this one, all have to add up, right? You have to add them all up to make 720 degrees. So the way we do this, though, you need a lot of algebra, is I'm going to go ahead and just add my x's up. So 1x here and 1x here. So 1x plus 1x is 2x. So I'm going to write 2x. So I'm going to write 2x plus, now I'm going to go ahead and add all my regular numbers. 140 plus 105 plus 30 plus 130 plus 100 plus 5. Add those on your calculator. So first I just added my x's. Now I'm going to add my numbers. Go ahead and do that real quick. Okay, good. If you added 5 plus 140 plus 105 plus 30 plus 130 plus 100, you should have gotten 510. So 2x, 2 times x plus 510 equals 720 because we figured that out right here. 720. And then now all you have to do is solve it. So I'm solving for x, so I need to subtract 510. So go ahead and subtract 510. Hey guys, please be working this out before I finish it. So go ahead and subtract, and then you're just going to do the last step, which is divide. Go ahead and finish it. Okay, so you should have had 2x equals 210. This is 210, so you divide by 2. So I divide both sides by 2. So 210 divided by 2 is x equals 105. So 105 degrees. So right here, this x should be 105. So 105 plus 30 is 135, right? And then 105 plus 5 is 110, 110 degrees. So if you add 140 plus 105 plus 135 plus 130 plus 100 plus 110, you should get 100. You should get 720 degrees. Go ahead and try that. Okay, I checked it also, and it does come out to 720, so we did this one right. Try this next one. So first count the number of sides, and then find out how many triangles there are. Go ahead and do that. Okay, good. You should have gotten 1, 2, 3, 4, 5 triangles. 5 sides. So 5 minus 2 is 3 triangles. So there are 3 triangles in here. So 3 times 180, go ahead and figure that out. So there's 5 sides, 5 minus 2 is 3, so there's 3 triangles, and 3 times 180. Figure that out real quick. Okay, you should have gotten 540 degrees. So that means that all of these angles, 1, 2, 3, 4, 5 angles, have to add up to 540. So we put them all equal to each other. So again, I have x's, so go ahead and add your x's. So there's 1x, 2x, 3x. So write 3x plus, right, 3x plus now, what is the sum of all of these here? 120 plus 92 plus 100 plus 60. This one doesn't have anything, so I have to add anything. So add 100 plus 92 plus 120 plus 60. What do you get? Okay, so you write your equation, then you solve it. So subtract 372 from both sides, then you divide by 3. Go ahead and try this. Look at your other examples as notes. Okay, you should have gotten 3x equals 168, and then you divide by 3. So 168 divided by 3 is what? Yep, 56 degrees. So x equals 56. So that means that this angle right here is 56 degrees. So this angle is 56 degrees. And then this angle right here is 56 degrees plus 60. So 56 degrees plus 60 is 116 degrees, and 56 plus 100 is 156 degrees. So this one's 156 degrees. So remember that to find the sum of all the interior angles, you count the number of sides minus 2, and that gives you how many triangles you have, and each triangle is 180, so you multiply by that, by 180. So I did that here. 3 times 180 is 540. Then I added all these, and I found the missing part by using my algebra skills. So I want you to go ahead and fill in this writing part here. It says, to find the total sum of the interior angles of any convex polygon, I need to, what do you need to do? Write what you need to do. Count the number of sides, Okay, I know you've learned this before, so I just put this here to remind you. And we're going to talk about, we're going to practice what we just learned. Okay, so there's that. If you want to copy that down, or you have it on your notes, actually, if you printed it out. So right here, you're going to identify the figure if it's concave or convex and name it by its side. Go ahead and do number 1, number 2, 3, 4, and 5. So like you're going to write concave or convex, and then you're going to name it by its side. So you're going to pick one of these up here. Take a minute to do that. Okay, use your notes. These are exactly the same. So you're going to find the interior angles of these polygons. Okay, then you're going to use algebra to find the value of x, and you're going to plug it back in to find out what the actual angle is. So re-look at your notes. If you're doing the Edpuzzle, I also have the notes in a video that I'm posting. So it's actually the same as this Edpuzzle. So you can go back, because with the Edpuzzles, you can't really go back. So look at your notes and do these. Number 6, 7, and 8. Okay, let's look at number 9. It says find the sum of the interior angles of any octagon. So an octagon has 8 sides, right? So to find the sum of the interior, you're just going to count the number of sides, minus 2, which is 8 minus 2, and then multiply that times 180 degrees. So what is that? So count the number of sides. There's 8 sides. So 8 minus 2. 8 minus 2 is, good, 6. So there's 6 triangles, and each triangle is 180 degrees. So you would just multiply 6 times 180, and that's going to give you the sum of the interior angles. So what is that answer? 6 times 180. Okay, let's go ahead and do number 10. Number 10 says find the sum of the interior angles of a 13gon. So that's just a polygon with 13 sides. So you do the same thing. Okay, number 11. Find the sum of one of the interior angles of a regular hexagon. So this one we'll do together. So a regular hexagon means that all the angles will be exactly the same size. So all we need to do is find the total sum. So the total sum of a regular hexagon, so hexagon is 6 sides. So I'm going to say 6 minus 2. So 6 minus 2 is 4. Very good. So there are 4 triangles inside any hexagon. There's 4 triangles, and each one is 180 degrees. So multiply 4 times 180. Okay, so that gives me 720 degrees. So inside the hexagon, it's 720 degrees. But I want to find exactly one. Oh no, it says find the sum of one of the interior angles. So I want one of the angles. So if there are six sides and there are 6 angles, all I have to do is divide this by 6. So what is 720 divided by 6? Could you divide 720 by 6? You should have gotten 120 degrees. So each angle is 120 degrees because they're all the same, because it is a regular hexagon. So each angle is 120. So all 6 angles, 120, 120, 120, 120, 120 plus 120 equals 720. Okay. We're going to do one more thing. Okay, we were talking about interior and interior. Now we're going to talk about exterior. Exterior is the outside. So these angles outside, looks like a pinwheel. All of these angles, so let's count them. 1, 2, 3, 4, 5. So it's the same as the number of sides, like 1, 2, 3, 4, 5. So the number of sides and the number of angles are the same. So all of these 5 angles are always going to add up to 360 degrees. Okay, not even just these, but any polygon, the exterior angles are going to add up to 360. So here's 1. I'm going to put a video on so you can see this also. 2, so there's 1 angle, 2 angles. So you extend the lines like the sides like a pinwheel. There's 3. Go ahead and do this on your notes. There's 4. So you're just extending it. There's 5. Here's 6. Here's 7. And here's 8. This is an octagon. Let me mark it. 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 sides. So this is an octagon. So it has 8 sides and 8 exterior angles and 8 interior angles. So all of these angles right here will all add up to 360. So what if I had a 10-sided figure? Would it matter how many angles there are on the outside? They all add up to 360. So you don't have to subtract anything. It's just always going to be 360 no matter what. Will always sum up to 360 degrees. So let's practice that theorem. It said that all of these angles are going to add up to, what did we say? Good. They're always going to add up to 360. Nothing else. They will always add up to 360 degrees. So that means 95 plus 85 plus 2x plus 2x equals 360. So let's do that the same way. Add up your x's first. 1x plus 2x, what is that? 1x plus 2x is, good, 3x. Okay, so now add up 85 plus 95. So what is 85 plus 95? Good, it's 180 degrees. So 3x plus 180 equals, and they're always going to equal 360 no matter what. So equals 360, and then you can solve it. Same way, I subtract 180 from both sides. Go ahead and do that, and then you divide by 3. Go ahead and do that. Okay, so I have 360 minus 180 is 180, and then I'm going to go ahead and divide by 3. So divide by 3 from both sides. So what is 180 divided by 3? And that's going to give you x. So 180 divided by 3 is 60. So x equals 60. So x equals 60. So now I found x. So then I know that this side is 60. And then this one is 60 times 2. So 60 times 2 is 120. So this one is 120 degrees. So 120 degrees plus 60 plus 95 plus 85 should give you 180. Go ahead and try that. 85 plus 95 plus 60 plus 120. It does give me, oh, I'm sorry, it gives you 360 degrees. That's what it should always equal. Every single, so all, even this other one here, all the angles, the exterior angles will always give you 360 no matter what. So go ahead and try this one. Add up all the angles. First do the x's, right? 3x plus 2x. What is 3x's plus 2x's? Good, that's 5x. So I'm going to put 5x plus, now add up 70 plus 65 plus 75. What do you get? Okay, so 3x plus 2x is 5x plus 70 plus 65 plus 75 should have given you 210. Then you just subtract 210, just exactly the same way you did this, and then divide by 5. Go ahead and do that. Okay, so last part. So we just learned that when you add up all the exterior angles of any shape, right? Any polygon, it will always give you 360 degrees, no matter what. Okay, always. So now we're going to find each exterior angle in a regular polygon. Remember, regular means all the angles and sides are the same, right? So then all of these angles are going to be exactly the same, right? They're going to be exactly the same. So they all have to add up to 360, right? So they're all add up to 360. So I have 1, 2, 3, 4, 5. This is a pentagon, so it's 5 sides. So I'm just going to do 360. They all share exactly the same. So remember, when they share exactly the same amount, right? They're exactly the same. You just divide because one is not bigger than the other. They're all exactly the same. So I'm going to divide it by 5. So what is 360 divided by 5? Good, it's 72. So then each one is 72 degrees. So that's all you do. 72 degrees. Each one will be 72 degrees. So I'm going to write 72 on each one. And then I'm done. 72. So go ahead and do that on your notes. 72. So all you do is you don't have to count. You don't, well, I guess you do to find out how many angles you have. But that's all you have to do. They're always going to equal 360. Do this one. This one has, what does it say? 8. So this is an octagon. Let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8 sides. So it has 8 sides. And it wants to find out the sum of its exterior angles will always be, good, 360. No matter if it has 8, if it has 100 sides, they'll still be 360 degrees. If it has 3 sides, they'll still be 360 degrees. The sum. So what is each one? If this is a regular polygon, what is each one? Good. You're going to divide 360 divided by each one. There's 8 of them, so you're just going to divide by 8. And what would you get? So each one would be equal to, go ahead and figure that out. And then that's all we learned today. So I learned that exterior angles will always equal what? What do exterior angles always equal? And how do you find each one if it is a regular polygon? All right, guys, I'll see you on Wednesday, okay? Have a good weekend. If you have any questions, please, please, please let me know. Bye.